These Soviet engineers are making history today. They have drilled the deepest hole on Earth, even deeper than the Mariana Trench, reaching 12.2 kilometers down. You might expect the geometry of the hole to look like this. Surprise! This is actually the geometry of the Kola super deep borehole, a hole that curves in an S shape. How did the Soviet engineers make the drill bit travel this way? Assume the drill bit has a bend like this. Nothing spectacular happens in it. It just drilled a hole with a larger diameter. But what if you spin only the bent portion? Take a guess. Yes, in this case, like magic, the hole gets drilled at an angle. Uh-oh, now it's turning into a circle. If you don't want to continue this circle, you know what you have to do. Just straighten the cutter head. It's beautiful to watch the drill progress like a snake. Using this clever technique, the Soviet engineers were able to achieve the exact path they wanted. But for the technology of 1990, this was not an easy operation. There was no automatic way to adjust the angle of the drill bit. Each time when they wanted to change the cutter angle, the Soviets had to pull the entire string up and change the cutter angle manually. Now, you might be wondering, how could they bend a rigid steel rod and drill a hole in this shape? Here's the fact. The 2-diameter rod is in fact very much flexible when it is 12 kilometers long. The most crucial part of this hole is this steel concrete lining. Without that, how did the Soviets insert this lining so precisely into such a deep hole?
Can this robot do this task? No, this is not at all a practical method.
The inspiration is right there in this Russian toy, nesting dolls. First, they added a steel lining and a bottom plug. Now they dumped concrete directly into the hole. Surprised? Here is the trick. Now another plug comes from the top and pushes the concrete down. Where will this concrete go? You are right. They are forced to enter between the casing and the hole. Now they start the next drill, destroying the plugs. The next steel casing has a lower diameter than the previous and more concrete injection. To go deeper, steel casing with even lower diameter and concrete injection, and this process repeats. In fact, the Russians never used the technology of spinning the whole drill string. The Soviet engineers were confident in their turbo drill technology, or spin-only bit technology. In the turbo drill technology, a hidden turbine set does this crucial job. A high-pressure fluid is pumped through the drill string. This fluid, when passed over the turbine, makes them spin. So is the drill bit connected to the turbine set. You might be surprised to know that the high-pressure fluid passing through the turbine is just mud. The flow of the mud is the bloodstream of the well. The journey of the mud starts from the massive piston pumps on the surface. After a long journey, the mud reaches the bottom, goes through the mud motor, spins it, and shoots out of the nozzles in the drill bit. This cleans the bit and cools it down. The mud then travels back up the space between the outside of the pipe and the rock wall. As it rises, it carries the cuttings to the surface. When the mud returns to the surface, it is dirty, filled with rock chips, sand, and sometimes gas. If you pumped that straight back down, the abrasive sand would destroy the mud motor in minutes. The solids control system cleans it in stages. At the Kola Super Deep, the filter system had to be incredibly robust. Because they were drilling through granite, the cuttings weren't soft clay. They were sharp, abrasive shards of quartz. After filtering the mud, the cycle repeats. Now, it's time to introduce the hero of the Kola Super Deep Hole project, Uralmash 15,000. A Soviet invention that did the unimaginable job of drilling 12 kilometers deep. Let's explore the secret of the biggest drilling rig built at that time. Uralmash 15,000 was in fact a factory, where the final product is a stable hull. The most visible duty of a rig is lifting and lowering massive weights. The rig must pull the entire drill string out to change the bit and then lower it back down. Remember, the weight of the drill string was a massive 200 tons. You may see the main muscle of the Uralmash 15,000 here, a fully electrically powered drawworks. The Soviet engineers knew that conventional diesel engines wouldn't give them the precise speed control or the sustained torque required to lift a 12-kilometer deep string of pipe. The power from the drawworks is transferred to the crown block, which is at the very top of the rig. Steel ropes which are coming down from the crown block are connected to a traveling block. The drill string is securely connected to the traveling block. The crown block, with the help of the steel ropes, do the job of raising and lowering the drill string. The drawworks on the Uralmash 15000 were powered by two massive direct current electric motors, each rated at 1,000 kilowatts. This gave the drawworks a combined capacity of 2,000 kilowatts, dedicated solely to turning the massive winch drum. The way Uralmash 15000 lifts and lowers the heavy steel lining is illustrated here. These steel linings stabilize the holes. The rig had one more duty. We know that cutting happens due to the rotation of the mud motor. The rig is supposed to spin the entire drill slowly, even though the drill bit spins independently. This rotation is very slow, typically between 2 and 10 RPM. Without this slow spin, the entire drill string may get stuck with the surrounding rock. You may enjoy the details of the rotary table which does this task. The rotary table is powered separately.
Here I have an interesting question for you. What will happen if the rig just drops the entire drill string? To answer this, let's have a closer look at the design details of the drill string. The drill string pipe is quite thick towards the top. Now let's pull it all the way up. Now let's take a section from the bottom of the drill string. The drill string pipe is quite thin towards the bottom. The weight of the drill string is a whopping 200 tons. Of course, allowing it to rest completely on the ground will crush the drill string.
What if the drilling rig carries the entire weight of the drill string? In this case, the tensile stress would be immense towards the top. A material failure will not happen, since the drill string is thicker towards this region. The issue is that, in this case, the rock cutting will be ineffective. Without sufficient cutting force, the drill bit will struggle. Uralmash 15000 had to carefully control how much of that 200-ton weight actually rests on the drill bit. We've already seen the bloodstream of the rig, the mud circulation. This is a common technology nowadays. But in the Kola Super Deep Hole project, the mud stream had to travel 12 kilometers down and still maintain a good pressure to spin the turbo drill, and eventually, after collecting all the debris, the stream had to reach the top again. The big question is, why did the Soviets spend 24 years and a small fortune drilling a 9-inch hole into the Arctic tundra? The most important reason, it was in fact a race to the center of the Earth that was every bit as intense as the space race, the Soviet Union versus the US. The US started Project Mohole in 1961. The US selected ocean floor for this drilling where the crust is thinnest, just 5 kilometers. However, this project was abandoned in 1966 due to massive cost overruns. The Americans only managed to drill 183 meters into the seabed, and this project is considered to be a failure. The Soviets hoped to find massive, deep-seated mineral deposits. They actually succeeded in this, discovering copper-nickel ore bodies and signs of gold at depths where no one expected them to exist. Just 4 years after the abandonment of Project Mohole, the Soviet Union started their race towards the Earth's center. They didn't use the giant Uralmash 15000 from the very beginning. From 1970 to 1974, they used a relatively standard Soviet rig called the Uralmash 4E. At depth between 1,540 and 1,800 meters, they discovered massive copper-nickel ore. This ore discovery was at a commercially viable depth. Prior to the Kola Super Deep Hole project, the Soviets didn't know that copper-nickel ore was present at such great depth. The granite the drill bit had to drill through was incredibly hard. As we saw earlier, the Soviets used their favorite turbo drill technology in all the stages of the project. During this stage, approximately after drilling 30 meters, the Soviets had to pull out the entire string. The reason? The wear and tear of the drill bit. By 1974, they drilled to 7,263 meters. We will explore the incredible journey of the Soviets' deep drill. But before that, let's check the safety record of this project. The Kola Super Deep Borehole has a clean safety record. There are no verified records of fatalities or major injuries, even though the project spanned 24 years and employed roughly 3,000 people at its peak. Now, consider a famous case handled by Morgan & Morgan, the 2010 Deepwater Horizon explosion. This was the largest offshore oil spill in U.S. history, claiming 11 lives and injuring 17 others. The blowout of the Macondo well caused a massive explosion on the Transocean-owned rig, which was leased by BP. Morgan & Morgan was part of the leadership team that fought to hold BP, Halliburton, and Transocean accountable. The firm helped secure a $13 billion settlement for impacted individuals and businesses. This included not only the rig workers themselves, but also thousands of local workers, such as commercial fishermen and coastal business owners. There's a reason some projects run safely for decades and others end in disaster. Just like there's a reason why Morgan & Morgan is America's largest injury law firm. If you are injured due to an industrial accident or someone else's negligence, having the right legal support can make a big difference in securing fair compensation. 2024 data from the U.S. Bureau of Labor Statistics shows that the oil and gas industry remains one of the more hazardous sectors. In 2024, there were 65 fatal work injuries in the U.S. and 8,300 recordable cases of injury and illness. If you're ever injured, you can check out Morgan & Morgan, and their fee is free unless they win. For more information, you can go to forthepeople.com/Sabin, found in the description below. In 1974, they stopped drilling for a year. This was a great transition period to the second stage of the project. They were dismantling the old rig and installing the massive 20-story Euromash 15,000 over the hole. The Euromash 4E simply didn't have the lifting power to go any deeper. The weight of the pipe was becoming too much for the motors to pull out. At this depth, they also switched from steel drill pipes to the specialized aluminum alloy pipes. The drill from 7,263 to 12,262 meters was done in this stage. Let's have a look at the scientific diagram of the borehole path the Soviets achieved. What, is this a diagram of a tree root? Why so many branches? The short answer, the engineers didn't want to do this. The story of these branches is a perfect example of heartbreak and human endurance. In June 1984, the Soviets reached 9,584 meters, thus officially overtaking the deepest hole at the time, Bertha Rogers Well of the US. The Soviets did not stop here for an announcement or celebration. They wanted to present a massive, undeniable lead to the world, not just an inch-ahead victory. During this stage, they had to pull out the string in just 5 to 10 meters. Look at the damage the extreme heat and pressure did to the drill bit. Pulling out the string, changing the drill bit, and lowering the string again would take anywhere between 18 to 20 hours. This is the reason drilling progressed in a snail's pace after crossing the 10-kilometer mark. Moreover, the Soviets were so keen in core sample collection. A special bit was used for this purpose. Again, to transport the core sample to the surface, they had to pull out the entire string. At around 9,500 meters, the Soviets had a surprising discovery: gold traces. The concentration of the gold was respectable. However, this gold deposit still remains as one of the most expensive treasures even today. If you try to mine this gold at the 9,500 meters, you would spend significantly more money trying to reach the gold than the gold itself is worth. On September 24, 1984, they reached a depth of 12,066 meters, and the engineers paused the drilling for the International Geological Congress. In 1984, Moscow hosted the 27th International Geological Congress. This was the Soviet Union's big chance to show off to thousands of Western scientists. They aimed their biggest announcements and site visits to coincide with this event. The American record obviously looked tiny by comparison. When they went back to work in September, they didn't just start the motor. They needed to pull the string up to check the condition of the bit after the long pause and to prepare for a fresh run. As the Euromash 15,000 rig began to lift the 12,066 meter string, it had been sitting still for a long time. The plastic rock had likely begun to grip the pipe and the drilling mud had settled. The static friction was enormous. As they applied the massive lifting force and a bit of torque to break the pipe free, the stress became too much. The pipe snapped, leaving 5 kilometers of the string at the bottom. Many engineers involved in the project later lamented that the long break for the celebration was what killed hole 1. In drilling, a still pipe is a stuck pipe. Anyway, in September 1984, the 12-kilometer long hole effectively reduced to a 7-kilometer long hole. The same thing happens to all of us in the snake and ladder game. The Soviets didn't give up. They had to go all the way back to 7,000 meters to start an entirely new branch. They started the process of whipstocking. They initially filled the lost portion of the hole with concrete. After that, an interesting piece called whipstock was introduced to divert the drill string. So clever, right? This branch is the famous one that eventually reached the world record depth of 12,262 meters in 1989. In 1991, they sidetracked again from hole 3 at 9,653 meters, reaching 11,882 meters before the project was finally halted due to the extreme heat and the collapse of the Soviet Union. At 12 kilometers, the temperature was approximately 180 degrees Celsius, nearly double what the geologists had originally predicted. Under such extreme conditions, the rock lost its brittle nature and began to behave like flexible plastic. How can you cut something which is flexible? Even when the Soviets drilled forward with great difficulty, they faced another challenge. When the drill bit moved forward, the surrounding rock would slowly flow into the newly created void behind the bit, an automatic healing of the hole. All these difficulties forced the Soviets to abandon this project in 1981. All the core samples the Soviets have collected is currently kept in the Zapolyarny Repository, Russia. This is a massive facility and holds 4 kilometers of core samples. Yes, you heard it right, 4 kilometers. Out of their 12-kilometer deep drill, they collected 4 kilometers of soil. This facility is the holy grail for geologists. Currently, scientists from around the world still visit this facility to conduct new tests on the samples using 21st century technology that wasn't available to the original Soviet team. The official target for the Kola super deep borehole was indeed 15,000 meters. They even renamed the project's rig the Euromash 15,000 specifically to match this target. On land, the Earth's crust is roughly 35 kilometers thick. Drilling to 15 kilometers would have reached nearly halfway through the continental crust. Scientists believed that at this depth, the rock would be billions of years old and would show the primal state of our planet's formation. Many Soviet engineers still believe that if they had ignored the Congress and just continued the drill, the rock might not have had the chance to seize the string. If they hadn't pulled the string out that day, or if they hadn't stopped to celebrate, they might have reached the 15,000-meter Mantle target. There's one more reason why the Soviets drilled this hole: humanity's geological blindness. We know more about the surface of the moon than we do about the rock 10 miles beneath our feet. Before Kola, everything we knew about the deep crust was based on seismic waves, essentially listening to the Earth's echoes. For decades, scientists believed in the Conrad discontinuity, a layer where granite turned into basalt. Kola proved it didn't exist. They found liquid water 6 kilometers deep. This was thought to be impossible because the pressure should have squeezed it out. Instead, they found fossil water trapped in fractured rock. They found microscopic fossils of single-celled organisms at nearly 7 kilometers deep. Finding life that far down, encased in 2 billion-year-old rock, changed our understanding of how early life survived on Earth. The Kola Super Deep project served as the primary testing ground for the advanced technologies that would eventually define the modern Russian petroleum industry. Before Kola, the oil rigs relied on rotary tables that spun the entire drill string. The Kola project forced the development of high-torque turbo drills. At 12-kilometer depth, the electronics used to send data to the surface kept frying. Soviet engineers had to invent new, high-temperature resistant sensors that could survive constant vibration and temperatures exceeding 180 degrees Celsius. They even developed specialized drilling mud that has become the backbone of modern oil drilling in places like the Caspian Sea. China's recent Shendetek 1 drilling project, which used state-of-the-art technologies, had to be abandoned at a depth of 10,910 meters. Its target was 12 kilometers. The issues were highly flexible rock and extreme temperatures. The Kola Superdeep borehole may remain humanity's deepest hole forever.
If there was a sudden power failure, can you imagine the effect of this on Kola Superdeep Hole project? A power failure means the mud pump will stop circulating the mud. The unlined portion of the hole is stable due to the high pressure of the mud. This means the hole could collapse. Even worse is that 100 degrees Celsius heat can bake the tools into the solid block of rock. A power failure can be fatal for this project. How did the Soviets guarantee an uninterrupted supply of electricity?
Luckily, this 20-year-long project was located near an industrial mining region. Unlike most exploration rigs that are off-grid and rely entirely on diesel, the Kola project was a permanent scientific facility. It was connected to the regional power grid of Murmansk. The Kola Peninsula is a powerhouse of energy, home to both the Kola nuclear power plant and a cascade of hydroelectric dams on the local rivers. In the Arctic, a power failure can be fatal. Due to this, power backup was crucial for this project. The rig itself utilized a diesel-electric drive system. Inside the 20-story enclosed tower, there was a dedicated room housing massive diesel generator sets. We have already seen the gigantic drawworks. In short, the entire site functioned like a small town, consuming roughly 5 to 10 megawatts of power at peak operation, enough to power thousands of homes. Currently, this mega project is in a completely abandoned condition. The legendary 12,262-meter hole itself is hidden inside the wreckage of one of the main collapsed buildings, sealed tightly by a heavy, circular steel cap. Before you leave, please don't forget to check out forthepeople.com. Take care. Bye-bye.